It's time to re-review the RTX 5070 up against the RX 9070 because, for one thing, launch reviews were mostly based on MSRP, and the 9070's MSRP seems to have been mostly fake. It settled in at about $600 for the lowest models, rather than the $550 that was its MSRP. The RTX 5070, on the other hand, has settled in at its MSRP, with multiple $550 models available, and I'm talking United States pricing. Your region could be different. Also, the 9070 XT version stole the show in launch reviews because its MSRP was meant to be $599, in which case it was the better buy over both the 5070 and the 9070 non-XT. However, at least in the United States, its available pricing is generally closer to $700, and the models that are in the $600 and something range are generally in extremely poor availability or just don't ever really come in stock at all. Which means that the 9070 non-XT version suddenly is one that we should probably focus a bit more on, and specifically its matchup against the 5070. Also, there's been a lot of talk about whether AMD's performance has improved since launch, with driver updates, game updates, Windows updates, etc. And so this is all completely fresh data. Now, what data are we looking at? Well, first of all, we need to keep in mind the price difference when we interpret the results. So at $600 versus $550, we're talking 9% more money if you're buying the 9070 over the 5070, and that's going to be important when we look at these results. Also, this is obviously going to need some time to break down. This is the 92 benchmarks that I just ran on these two GPUs. Again, fresh game updates, driver updates, all of that. And yeah, 92 benchmarks, but it's not 92 different games. Instead, I focused on major releases of 2025. Plus, I did also throw in Cyberpunk as like a path tracing test, but I also had some RT Ultra and some just medium settings with RT off to kind of balance out those results as well. Speaking of that, in all of these games, I've tested out both maximum settings as well as medium settings because I know not everybody games at maximum settings. Now, if the game has ray tracing available, the max settings include that ray tracing. If the game allows ray tracing to be turned off, which not every game does, like Doom the Dark Ages, the medium settings have had the ray tracing turned off. But also, a lot of people don't actually game at native resolution. So we've also here looked at upscaling, but also native. So I have 1080p results, 1440p results, and 4K results, all at native resolution at both max and medium settings, but also at 4K, I've looked at performance mode upscaling, and I've at 1440p looked at balanced mode upscaling. 1080p I've mostly stuck to native resolution, other than in Cyberpunk, where I also looked at quality level upscaling, especially because we had some path tracing results in there to take a look at. Now, this is still an incredible amount of data to sort through, so we might also want to look at this. So this is taking all of that and instead looking at the percentage advantage of the 9070 over the 5070, which averages out to 11% faster overall. Now, it doesn't win every result, and some results are bigger wins than 11%. So the positive values you see here are its percentage advantage in that particular test. The negative results are its percentage deficit. Now, some of these results are obvious outliers. That happened when we saw VRAM become an issue on the 12 gigabyte card. So another thing we could look at is sorting the data like this. I sorted the results from highest FPS to lowest FPS, and then I said, okay, I need to pick some arbitrary number at which point I think the results are meaningless because neither GPU is particularly usable. I considered using 30 FPS for that. I figured I'd get some pushback from people saying that's a way too low. They wouldn't play under 60 FPS. So I kind of went with a happy medium and said, you know what, what if we erase anything below 40 FPS? But sometimes one GPU is at 40 FPS, the other one's below it. So I kept any result where at least one of the two graphics cards had at least 40 frames per second in the result. By doing that, we get rid of the stupid results where it's like one GPU's at 2 FPS and one's at 10 FPS, and that's a 500% advantage, if that makes sense. Now, if we sort that by percentage advantage now, we can see that it eliminates those crazy outliers, and the 9070 is now showing 9% faster. It also costs 9% more money. So that means that we're going to need to talk about whether AMD can really justify 9% faster, 9% more money based on other differences. But like we saw, VRAM can matter, and we are talking 16 versus 12. But the other thing we should talk about is how you should fund your upgrade if you're planning on buying either of these. You should sell your GPU, your old GPU, to fund the upgrade, and Jawa.gg is the place to do that. One thing is you can click the Get an Instant Offer button to get it, well, an instant offer. This is maximum convenience. It usually just takes a few days to complete the whole process. They give you an offer. If you accept it, they give you a shipping label you can print out. You send that in. Usually within a couple business days of them receiving it, you get the cash. But you can also create your own listings, join the marketplace, and honestly, guys, some of the best deals on PC parts right now are actually in the used market, so you should definitely check that out. Because Jawa is where you buy, sell, and upgrade between gamers, and also if you find a great deal here, I can make it even better for you using code OWEN10 for $10 off your first purchase. A huge thank you to Jawa for sponsoring this video. Another thing I want to point out is that you can shop for complete pre-built systems. You can shop by theme, performance in certain games, certain hardware. It's really awesome. If you haven't checked them out, check them out. Jawa.gg, link in the video description and or pinned comment. And again, they have sponsored this video, which allows me to dedicate just a ridiculous amount of time to testing. So let's get back to the testing results. This is going to be a long video because I have an hour and a half of side-by-side footage that we can go through now. Now, obviously, I'm not going to just play all of it. The video would be way too long. However, I do have, for channel members, I'm not talking over it. I've just uploaded all of the side-by-side footage as like a member's extra because on the main channel, I don't think an hour and a half of silent side-by-sides really makes sense. But that's available there as a thank you if you've clicked the join button. There's that. But what are we going to look for in these side-by-sides? So one thing we can look for is things like the frame time graph and VRAM allocation versus per process usage. We can look for all of those types of things, which are kind of obscured by those giant bar graphs. So we get more information here. Also, if you're looking things like the temperatures the GPUs are running at and things like that, remember that that really only applies to these specific models. So again, the Acer Nitro for the RX 9070, not the Sapphire Nitro Plus, those are different cards. And then also, again, the RTX 5070 gigabyte gaming OC. So if you're looking at temperatures, there's that. These are all running at their out-of-the-box settings. And let's go ahead and play the footage as we talk a little bit more about the results. So again, we're going through a massive number of tests, 92 results here at 4K, 1440p, 1080p, max settings, medium settings, etc. Upscaling on, upscaling off. At max settings at 4K in Spiderman 2, neither GPU is doing well here. It's 23 FPS versus 20, although the 9070 is interestingly winning by 15%. But again, this could actually be a situation where VRAM is an issue because the AMD card is showing above 12 gigabytes of allocation in this game. Now, if we go ahead and kick on upscaling, and there is FSR4 available in this game, we're seeing that the 9070 now increases its lead to 32%. Notice, though, that we're still showing over 12 gigabytes of allocation on the card that has it, which means that I think what's going on here is that these results are being impacted by the VRAM situation. However, the 9070 is only hitting 41 FPS here versus 31 on the 5070, so realistically, I think these settings are a bit too demanding for both GPUs. Now, at 4K medium settings, native resolution, we're actually pretty playable even at native res here. We're seeing 67 FPS versus 56, which puts the 9070 20% faster than the 5070, and again, both of them are completely usable. However, if you go ahead and kick on upscaling, which I was trying to skip to here for a second. Let's just let it play through. I think I skipped over it because I did test out upscaling here because really, honestly, at 4K, a lot of people really should be using upscaling. The newer models look quite good at these settings, and here we go. Massive performance increase. So 4K medium DLSS and FSR performance. Again, the FSR4 model looking perfectly good here. We're getting 122 FPS versus 117. It's now only a 4% lead for the 9070. So the performance lead is dropping, and I think that the 12 gigabyte card is now more comfortable given that we're at reduced settings and lowering the internal rendering resolution using DLSS. So That's where we are at with that, and I think that explains why our performance lead may have dropped there a little bit. At 1440p max settings, the 9070 is winning by 6%, and again, this includes maxed out ray tracing settings. This is fairly playable at 50 FPS versus 47, but I think would be more playable if we were using upscaling. So I will test that out as well. But again here, I think that the that NVIDIA is being more efficient on VRAM than AMD here. I've seen that in a lot of my tests because the 12GB card doesn't seem to be suffering as much here, even though the AMD card is showing over 12GB of allocation. If we go to FSR and DLSS balanced mode, we can see that the 5070 actually takes the lead, although it's really closer to a tie. Although the 5070 is actually showing better 1% lows. There's actually some signs that VRAM is still kind of borderline here, especially actually interesting on the 9070, where I see a couple of frame time spikes which indicate VRAM stuff. So despite having more VRAM, I do see some signs that the AMD card is actually struggling a bit more with it. And I have seen, like I said, NVIDIA be a lot more efficient with VRAM usage on some tests in the past. So interesting to note there. Anyway, at 1440p medium settings, we're seeing both GPUs getting high frame rate experience at 121 versus 104. That gives the 9070 a 16% advantage in this test. And realistically, you could probably stick to native resolution here if you wanted to. Don't need to upscale. We're already breaking 100 FPS in a single player title. That being said, I did, of course, also test out FSR and DLSS balance, which gets frame rates up to 172 and 162, 6% lead for the 9070. Now, at 1080p maximum settings, we're seeing 79 FPS versus 71, so both are very usable, 11% lead for the 9070. And if we switch down to 1080p medium, it's 170 FPS versus 146, so high frame rate on both, 16% advantage for the 9070. In Doom the Dark Ages, actually, let me go back a second here. So in, I'm trying to skip ahead, but not quite that much. This hour-and-a-half long benchmark footage is a little bit unwieldy. Anyway, let's go ahead and jump right there. So in Doom the Dark Ages, which requires ray tracing, we see the 9070 still take a 7% advantage at max settings other than path tracing. The only path tracing game I tested was Cyberpunk for this video. This is the max settings other than path tracing, but 7% lead for the 9070, hitting 44 FPS versus 41, so you'd probably want to use upscaling. Now, this brings out one of the disadvantages for the 9070. This game does not offer FSR 4, so even though our performance lead jumps to 16% at 88 versus 76, I would say the left-hand side of the screen looks noticeably sharper. Again, in YouTube compression, it might be a little harder to spot, especially in dark scenes, but it does look noticeably better, and Vulkan does not currently offer FSR 4 support. So that is, I think, the reason why we don't see it yet in this game. Now, dropping to medium settings, which, keep in mind, do still include ray tracing, at native resolution, we're seeing 49 FPS versus 45, which again is usable, but you'd probably want higher performance by turning down settings and or using upscaling. We're seeing the 9070 taking a 9% lead. So, 9% advantage, may or may not actually use these settings, and if we then do kick on the upscaling, we actually see the 9070 increase its lead to 20% at 100 versus 83, but once again, this is a case where the 9070 is faster, but the image quality doesn't look as good, given we have DLSS 4 up against FSR 3 in this game. Once again, the lack of FSR 4 support in a lot of games is disappointing, but the fact that this game is Vulkan means that I don't even think Optiscaler will work to mod FSR 4 into the game. At 1440p max settings other than path tracing, so Ultra Nightmare, we're at an 8% advantage for the 9070, and both GPUs are actually quite usable at native resolution. We're seeing 79 FPS versus 73. So this is a situation where you certainly don't have to use upscaling, and on the 9070, I would probably choose not to since we don't have FSR 4 available and frame rates are already pretty good. However, on the 5070, I probably would use DLSS 4 at like the balanced mode, and that gets frame rates up to 105. The 9070 using FSR balance gets up to 122, so 16% performance lead. But once again, it doesn't match the image quality of the 5070. So it's really a case where I'd probably use the 9070 at native, where it was getting like 79 FPS, and the 5070 with DLSS 4 looks pretty competitive and actually has a higher frame rate. So again, GPU buying decisions are more complicated than just looking at the frame rates. 1440p medium settings, again, still does use ray tracing, and the 9070 is hitting 90 FPS now at native. So actually, if I was playing this game on the 9070, there's a good chance I would play at native 1440p, but using the medium preset, which hits 90 FPS. The 5070 hits 80, so you could certainly use these settings as well. But on the 5070, I might have used, Ultra Nightmare plus DLSS. Now, if we're on the medium settings, we could, of course, also use DLSS. So if we check out DLSS and FSR balance, the 5070 is now hitting 116 frames per second, and the 9070 is hitting 141. So the 9070 is 22% faster, but once again, image quality not as good on the right-hand side of the screen. So it's one of those situations where you're going to have to decide how you want to use the game, and I think depending on which GPU I had here, I might make different decisions. Now, at 1080p native resolution, I think both can just use Ultra Nightmare and not really have to worry about any upscaling or anything like that. We're hitting 111 FPS versus 100, which makes the percentage math really easy here. It's 11% advantage for the 9070. And again, don't really need to use upscaling here. However, of course, you could. And with DLSS 4, I maybe wouldn't even mind doing that. Because with the new DLSS 4 model, I don't really mind the quality level upscaling at 1080p. That being said, for this video to not have even more ridiculous number of tests, I'm going to usually leave off upscaling at 1080p on these cards because they usually hit high frame rates without it. 1080p medium settings are a 14% advantage for the 9070 at 127 versus 111, and again, that's at the native resolution and does still include ray tracing because this game always uses ray tracing. There's no turning it off. Let's move to my favorite game of 2025, which is Clair Obscur Expedition 33, and at 4K maximum settings, which are the epic settings in this game, we don't really have amazing frame rates on either GPU, although it's playable. I probably wouldn't choose to use these settings. The 9070 is winning by 16% though, at 43 FPS versus 37. Now, if we kick on upscaling, this game does not have FSR4 support. You could try modding it in via OptiScaler, but this game doesn't have any FSR at all, honestly, if you're not using mods. So I had to use XeSS, which doesn't look as good as DLSS here, and it's a little more performance cost. So we're only down to a 5% lead performance-wise, but worse visuals on the 9070. At 4K medium settings, we're now hitting 69 FPS, which is pretty nice, versus 61 on the 5070. So the 9070 is 13% faster here, and they're both completely playable at native 4K resolution, as long as you're willing to reduce to medium settings. That being said, I would probably use upscaling. DLSS performance mode gets the 5070 up to 93 FPS, and the XeSS 50% internal resolution to match the DLSS internal resolution actually makes the 9070 only hit 91 FPS, which is a little slower and doesn't look quite as good. Using 1440p, we're seeing epic settings, which are the max settings in the game, reach 55 FPS on the 9070, and the 5070 is only hitting 47. So if you're going to play at native max settings, the 9070 is noticeably more usable here, and faster by 17%. That being said, on the 5070, I'd probably be using DLSS, which would get me to DLSS balance hits 80 FPS. The 9070 has to use XeSS, matching internal resolution, gets it to 86 FPS, so down to an 8% lead. But also, again, if you look at the left versus the right, I do think DLSS is noticeably sharper than XeSS. Not that XeSS isn't usable. Now, 1440p medium settings and native rendering resolution gets the 9070 up to 89 FPS versus 77 on the 5070, so it's a 16% advantage for the 9070, and both are very, very usable at native 1440p medium. However, using DLSS balanced gets the 5070 up to 118 FPS, and the 9070 basically ties it at 119 FPS performance-wise, but with slightly blurrier looking visuals to my eye because it's relying on XeSS rather than FSR4. At 1080p max settings, we're at 78 versus 66, so both do well. 9070 is 18% faster. And at 1080p medium settings, we're at 119 versus 103, so 16% faster on the 9070. Moving on to Monster Hunter Wilds at 4K max settings, including the RT set to high, we are seeing the 9070 27% faster, but not at the most impressive frame rate of 42 FPS versus 33 on the 5070. So I'd probably use upscaling and or reduce settings on both. Using DLSS and FSR in the performance mode, and here we do have FSR4 support available. And to be clear, despite this game really wanting to convince you to use frame generation, I want to be clear, I'm not using frame generation in this video. When I'm using DLSS and FSR, it is the upscaling, not the frame generation. Here we're seeing the 9070 17% faster now at 63 FPS versus 54. So they are both usable now at 4K max settings, other than using upscaling. And both look pretty good here, but the 9070 is still faster despite this having ray tracing, and is the only one to be over 60 FPS. Using 4K medium, we are, and by the way, that turns ray tracing off now as well, we're hitting 52 FPS versus 42, so they're playable here at native 4K medium, but probably not the settings you choose to use, and the 9070 is 24% faster. Using DLSS and FSR performance mode upscaling here, we now hit 77 FPS and 66, and the 9070 is now 17% faster. And these are probably more like the settings I would use if I was using these GPUs on a 4K display. Now moving to 1440p at max settings, including the ray tracing, both GPUs are playable, but the 9070 is noticeably faster by 27% at 66 FPS versus 52. That being said, using DLSS and FSR balanced gets performance up to 83 and 67 FPS, putting the 9070 24% faster, but the 5070 is completely usable here. At 1440p medium native resolution, we're seeing 83 FPS versus 64, so similar results to the max settings with DLSS and FSR balanced. 9070 is 30% faster here, and using DLSS and FSR balanced gets it up to 103 and 82. The 9070 is 26% faster now. Using 1080p max settings, which does include ray tracing, we're at 84 versus 66. The 9070 is 27% faster. And at 1080p medium settings, it's 103 versus 79, and the 9070 is 30% faster. Switching over to Oblivion Remastered at 4K max settings, actually need to turn off upscaling first. Here we are at 4K max settings, it's 28 FPS versus 25, so 12% advantage for the 9070, but neither GPU is particularly usable. Kicking on DLSS and FSR at the performance mode gets us to 55 FPS versus 50, 10% lead for the 9070, but look at the 1% lows in the frame time graphs. The 5070 starts spiking from time to time much more aggressively than the 9070 does. I think this could potentially be VRAM related given the allocation we see on the 9070, leading to much better 1% lows on those results there. At 4K medium, software lumen low, we are at 54 versus 43, so 26% advantage for the 9070, and the 1% lows are still an advantage, but less extreme at 46 versus 33. Kicking on DLSS and FSR performance mode gets us to 99 versus 94, 5% lead for the 9070, but again, a more extreme advantage in the 1% lows at 81 versus 55. And at 1440p, let me let it slide over here, because again, I almost skipped over the benchmark when I skipped ahead here. At 1440p max settings, we are seeing 47 FPS versus 41, so neither one doing particularly great. 15% lead for the 9070, and again, this does include hardware RT. The 1% lows are 36 versus 20, so a larger advantage for the 9070, and again, some of that could be due to the VRAM situation. Using DLSS and FSR balanced gets things to playable performance here at 74 versus 65, and 14% lead there for the 9070. 1440p medium, it's 101 versus 79, 28% lead for the 9070, and 1440p medium with DLSS and FSR balanced is now an 8% lead for the 9070 at 140 FPS versus 130. For 1080p maximum settings, which again includes hardware RT, is 65 versus 57, 14% advantage for the 9070. And 1080p medium settings, software lumen low, so no hardware RT now. We're at 143 versus 115, 24% lead for the 9070, and a larger advantage in the 1% lows. In Kingdom Come Deliverance 2, let me actually go back there for a second. Kingdom Come Deliverance 2, 4K maximum settings. Neither GPU does particularly well here. 34 FPS versus 29. The 5070 actually has the advantage here. 9070 only reaching 85% of the performance, but that wasn't particularly usable. Kicking on performance mode upscaling, we do have DLSS 4 and FSR4 available in this game. The 5070 is arguably playable now at 50 FPS, still probably not the settings you choose to use, and the 9070 is only reaching 39. So the 5070 has a large advantage here. 4K medium settings, though, even at native 4K, it's playable on both GPUs, and the 9070 has a 6% advantage at 74 versus 70. 4K medium, using DLSS and FSR in the performance mode, hits 121 and 119, so it's basically a tie. 9070 is 2% faster. And if we use 1440p max settings, we're seeing the 5070 is somewhat playable at 52 FPS, and the 9070 is okay, playable, but probably not what you'd use at 40. Not that I necessarily want 52 FPS on the 5070 either, but definitely a big lead here, and this is within the playable territory. However, using DLSS and FSR balance gets the 5070 up to 62 FPS average, whereas the 9070 is only at 46. So it's definitely a choice you could make to play the game at these settings on the 5070, whereas the 9070 is falling very noticeably short here. In 1440p medium settings, it's basically a tie at 137 versus 134, and it's actually the 5070 with the lead here, so this game just overall seems to be a little more NVIDIA favored than what we've seen in other tests. And using DLSS and FSR balance gets us to 180 versus 186, again 5070 with the lead. 1080p max settings are playable on the 5070 at 62 FPS, whereas the 9070, again, you could play at 46 FPS, but you'd probably not. Again, a big lead here for the 5070. 1080p medium gets us to 199 FPS on the 5070 and 186 on the 9070, so 5070 taking the lead here. And let's move on to Assassin's Creed Shadows. At 4K max settings, including maxed out ray tracing, neither GPU is very usable. Although the 9070 does take a 15% lead here, it's possible there's some VRAM related issues on the 12GB card, considering the 14 gigabytes of allocation we're seeing on the 9070. But again, allocation and usage for VRAM for AMD versus NVIDIA is not always the same. But again, probably wouldn't use a 31 FPS experience here. Using DLSS and FSR performance mode, we do have the version 4 of both upscalers here. The 9070 is hitting 53 FPS, the 5070 is hitting 49. It's an 8% lead for the 9070 despite the ray tracing usage. And, playable frame rates here, you may or may not choose to use these settings, though. It's a single-player game that you'd probably be using on a controller, though, so maybe. 4K medium settings at native resolution actually gets us to 65 FPS versus 51, 27% lead now for the 9070. And note that this is the RT set to as close to off as we can get. It's set to hideout only, so I think that is only in, I don't think this benchmark run goes through the hideout, so it's effectively RT off. Now, if we move to 4K medium RT off DLSS and FSR performance mode, we're hitting 94 FPS versus 91, so it's essentially a tie, 3% lead and 3 FPS for the 9070. 1440p max settings, we're at 48 versus 42, so it's a 14% advantage for the 9070. And at DLSS and FSR balanced, it's an 11% lead for the 9070 at 62 versus 56, but they're definitely both playable here. And then dropping to 1440p medium with the RT turned off, it's an 18% lead for the 9070 at 94 versus 80. Switching to 1080p max settings with maxed out RT, it's 59 FPS versus 50, so 18% lead for the 9070. And again, playable numbers here, almost 60 FPS on the 9070. And 1080p medium with the RT effectively off, we're at 110 FPS versus 98, so nice high frame rate experience, and 12% lead for the 9070. In Final Fantasy, which we'll switch to next here, give it a second here, but we're switching to Final Fantasy VII Rebirth. At 4K high settings, we're seeing a 5% lead for the 9070, and it is playable at native resolution maxed out 4K here at 65 FPS versus 62. Now, the fact that it is usable at native 4K here is pretty significant for the 9070, because this game does not have FSR. It also does not have XESS. If you want to upscale without modding in using Optiscaler, you are going to be stuck to TAAU. Now, TAAU does not look very good. TAAU is honestly just pretty ugly. So that's going to be important to note as we switch over to the upscaling result here. So here we're looking at DLSS performance mode versus TAAU 50%. And I think you can tell it's extremely blurry on the right-hand side and extremely sharp on the left-hand side. So while the 9070 is 14% faster, it's a much better experience on the NVIDIA GPU. Also note that this game does have a 120 FPS cap, so we are kind of bumping into that at times here, which is also why I'm not going to test out reduced settings in this game, and there's just going to be less settings tested overall in Final Fantasy VII Rebirth because I was trying to avoid tests where the 120 FPS cap started to influence the results very significantly. But I did want to show you this side-by-side footage because it is bad for the AMD hardware. However, Optiscaler does work well here. Now, 1440p, you don't really need to use upscaling on either GPU. You're hitting 100 FPS versus 95, 5% lead on the 9070. And 1080p max settings were basically bumping into the 120 FPS cap on both GPUs. So they're basically both able to max out the game at 1080p with no problems. Let's switch over to Cyberpunk. Now, everything else I tested in this video is focused on games released in 2025. However, Cyberpunk is a ray tracing showcase, so I did want to at least take a look at the ray tracing performance in depth in this game on these GPUs. So RT Ultra, both GPUs are effectively tied, and that's at native resolution, 45 FPS. Also, this game did just get its FSR4 update. Now, I switched over to drivers that do allow me to use that, whereas the public driver for FSR4 in this game haven't yet been released. But here we are looking at FSR4 versus DLSS4. RT Ultra, 1440p, balanced mode upscaling. And you can see that the 9070 is extremely usable here. 91 FPS versus 89, and the FSR4 upscale looks good. This is a complete turnaround from what we saw in Cyberpunk when it launched, and for AMD GPUs just throughout the history up until the 90 series. That being said, the path tracing mode, which I'll switch to here, is another story. So 1440p path tracing at native res does not work well on either GPU, but the 5070 is faster by 19%. Also, I noticed that there's a bit of a pinkish hue that I don't think should be there on the right-hand side when you look at those reflections and other things here. So it also seems like the RT overdrive mode is not working quite as intended on my testing here on the 9070. Now, we can also kick on DLSS and FSR4 balanced mode, which now gets us to more playable frame rate numbers, but the 5070 is still winning by 16%, but also has better image quality. Ray reconstruction puts in a lot of work here and is, I think, noticeably better looking. And AMD does not yet have Project Redstone finished, which should have their own AI denoiser for path tracing, and it's also unclear which games will get support for that. Hopefully at some point that will launch, hopefully it will be good quality, and hopefully it'll make its way to Cyberpunk. But I think it's important to note that none of that's there yet. Now, I did also want to mention, if you're not using ray tracing in this game, that the 9070 is faster. 1440p medium is 13% faster on the 9070, and if you want to play this game at a true high refresh rate experience, both GPUs are capable of doing it if you choose the right settings. We're looking at 159 FPS versus 141. Using DLSS and FSR balanced on the medium preset gets us to 222 versus 196, 13% faster on the 9070. So it's really impressive how scalable Cyberpunk is. You can absolutely crush the latest GPUs with native path tracing, or you can scale down to medium settings with upscaling that still looks good and hit triple digits, even going into the 200 FPS mode. So kind of an interesting game to benchmark, really. Now, 4K RT overdrive is the 9070 is 500% faster. Well, actually, 400% faster, 5 times the performance. The point is, this is just an unusable result. This is one of those big, it looked really big in the bar graph, right? When we looked at percentage differences, but I said it was an outlier. Look at this. The 9070 is not running this at an acceptable frame rate. The 5070 is just completely broken slideshow at 2 FPS, but guys, 10 FPS isn't good either. If we switch to FSR and DLSS performance mode, we're now more like a 30 FPS experience. The 5070's approaching somewhat playable if you really wanted to, play the 4K path tracing. You get 39 FPS here. It's 22% faster than the 9070, and again, looks a bit better due to ray reconstruction and all of that, but not an amazing experience. I would not buy a 5070 for 4K path tracing. Now, 4K RT Ultra, even though it's not path tracing, is also something that's going over 12 gigabytes of VRAM, but still isn't very playable on the 9070. So 83% advantage for the 9070, but it's only 22 FPS versus 12. If we kick on DLSS and FSR performance mode, it's actually very usable here. Check this out. These GPUs, and again, DLSS and FSR 4 performance mode look good here. 60 FPS and versus 58 FPS, so it's basically a tie. They're both around 60 FPS at RT Ultra. No, it's not the path tracing mode, but this was the original max ray tracing settings for the game. Kind of cool that we're able to get there on GPUs that, while expensive, aren't completely out of reach. Now, 4K medium settings, native resolution is 83 FPS versus 73, so completely playable at native 4K if you choose the medium preset. It's a 14% lead for the 9070, and if you do kick on DLSS and FSR performance on the medium preset, even on a 4K 120Hz display, you can actually use your 4K 120Hz. It's 149 versus 128, 16% advantage for the 9070. And now 1080p RT Overdrive native resolution, the 5070 is 14% faster at 40 FPS versus 35. You could play it this way, but honestly, if I was on the 5070 on a 1080p display here and wanted to do path tracing, I'd probably kick on DLSS quality mode with ray reconstruction. If I do that, we get up to 74 FPS, which is 16% faster than the 9070, which is hitting 64. Completely playable frame rate here, though, to note on the 9070. Again, hopefully that pinkish tint gets looked at with either a driver update or a game update, whichever way it needs to go, because that doesn't look quite right here. Now, 1080p RT Ultra at native resolution is actually completely playable on both GPUs here, 72 versus 73. It's a tie, 1% lead and 1 FPS lead for the 5070. And using DLSS and FSR quality, which again with the version 4 is completely usable, we're now in the triple digits at RT Ultra. 115 FPS versus 113, 2% lead and 2 FPS lead for the 9070. Now, if you drop down to 1080p medium at native resolution on, like, maybe you usually play esports, so you have like a 240 hertz display, hey, you can do that. 229 FPS versus 206, 11% lead for the 9070. And I even tried out DLSS and FSR quality on the 1080p medium, because again, version 4 is pretty usable even at 1080p quality. We're hitting 272 FPS versus 246, 11% lead on the 9070. And that is all 92 benchmarks that I ran here. In reality, I actually ran even more because I'm insane, because I did even more upscaling at 1080p, but it was just starting to get to a completely unwieldy amount to actually do in a video. So again, this was the overall summary of all of the tests, but that's a lot to look at, and I really think that it would make more sense to pare this down into more digestible chunks. Remember, the overall percentage advantage was an 11% lead for the 9070 in all tests, but we had those outlier results that I don't think made sense to actually use. And if we limit it to just results where at least one GPU was hitting 40 FPS or better, it looked like this, and we had a 9% lead on the 9070. Now, let's also break it down, though, by monitor resolution. So what if you're on a 4K display? Now, I actually think both of these GPUs can be used at 4K. I don't think there's anything wrong with that decision as long as you're going to be using upscaling when needed, which in the latest AAA games is going to be often. Although oftentimes the medium settings are still usable at native resolution if you prefer. Now, we see the 50 FPS line here, and we can see that most results in these games we can get above that as long as we're using the right combination of settings and graphic settings, presets, and upscaling. So they're very much usable at 4K. And the overall percentage difference is a 16% advantage for the 9070. But again, these two outlier results, where we were well over 12 gigabytes of VRAM, but in a situation where the 9070 was not actually usable, if you just throw those two results out, I recalculated the geo mean to a 10% advantage for the 9070. So, on a 4K display, both cards are usable, but will often have to turn down settings and use upscaling. and you get 10% faster result on the 9070, but we also see that that 16 gigabytes of VRAM certainly is showing places where it pays off at 4K, but not always at settings that are particularly usable, although some of them were kind of borderline on that 12 gigabytes, and I think that's where some of these larger wins are happening. We're seeing these 27%, 24%, 32%, 26%. Some, but not all of those can be VRAM related. I think that's important to note. But I think these GPUs, most people looking at these are probably on a 1440p display. So let's focus a bit more on 1440p. Now, the 1440p results, I do want to actually look at what if we focused on 1440p ray tracing, because the reason is in the past, this has been a big selling point for NVIDIA GPUs. But what's interesting here is other than in path tracing, NVIDIA doesn't really have a ray tracing advantage, which I think is, pretty surprising, okay? And if we look at this as percentage differential, it looks like this. The 9070, even in ray tracing, is averaging 8% faster overall, which is similar to our overall averages. And it's really only in path tracing where we're seeing that advantage for the 5070. Pretty interesting. If we go to 1080p, by the way, we can also see similar results. Overall, we're really seeing similar results to all of the tests. The 9070 is somewhere between 8 to 10% faster, depending on resolution. And but then when we look at the price, that kind of puts a damper on things, right? So remember, the 9070 at $600 versus the 5070 at $550 means you are actually spending 9% more money, and you're effectively getting about 9% more performance. So which GPU should you buy? And this is where we would say that they're offering equivalent raw performance value. And generally, if you're getting similar raw performance value, I would recommend buying the NVIDIA GPU instead due to improved feature set. However, this particular comparison does, I think, need to be a little bit more nuanced than that, because these GPUs don't have the same VRAM capacity. We're looking at 12 gigabytes versus 16. Now, this is where your personal opinion and my personal opinion might differ, and we can both be correct. And I think we'll get a lot of differences of opinions depending on who you ask and what you look at in the comment section. What should you value more? NVIDIA's generally better feature set, for example, DLSS 4 is available in way more games, and FSR 4 often needs to be modded in using Optiscaler. Now, Optiscaler is pretty easy to use, and I've done videos on this, but it has some downsides. The downsides can be, one, if you're playing an online game with anti-cheat, you can get banned for modding game files, so it kind of rules that option out. And then there's also games like Doom: The Dark Ages that are in Vulkan, where I don't think that one works out yet, because I don't think FSR 4 has Vulkan support yet. And then also, just the hassle of doing that, having to mod it in, and occasionally games crash. Like recently I was trying to use it on Wuchang Fallen Feathers, and I was getting it to crash when I tried to launch the game when I had Optiscaler installed. Tried a couple different versions, including the nightly build, and I couldn't get it to work. I saw other people telling me it was working for them, though. So I think that in general, DLSS 4 and FSR 4 are very good. DLSS 4 looks slightly better. FSR 4, though, is completely usable. The real distinguishing factor there to me is how much better supported DLSS 4 seems to be overall. And I think as AMD starts to release more Project Redstone and things like that, if the past is anything to judge by, I have a feeling, that they will lag behind in the game supported list. So for me personally, especially if I was on a 1440p or 1080p display, I would choose, at basically equivalent performance per dollar, the NVIDIA GPU, even with the 12 gigabytes of VRAM, because for me, not having to worry about game support for big features like DLSS 4 is a big deal. Not having to mod it in, worry about anti-cheat, things like that. That would push me in that direction personally. And it's a bit less money in this case. Now, I could see a lot of people making the other decision. which is saying that 12 gigabytes of VRAM is already showing some situations where it's causing problems, and that is likely going to increase over time how frequently that will cause issues. However, I'm confident that with some minor graphics tweaks, 12 gigabytes will be very usable at 1440p for a very long time. But it is possible that you will be more and more frequently having to turn down certain graphic settings and monitor the situation on the 12 gigabyte card. That is a very real thing. So I could see a lot of people opting for the 16 gigabyte card instead. So out of this video, I wish I could come to a strong conclusion on which GPU you should buy, but I actually don't really have that being the case. They offer similar performance per dollar. The 5070 offers better support for things like DLSS 4 feature set, and the AMD GPU offers more VRAM. Which of those you value more? Think about personally, and also look at the pricing in your market, which could be different. Again, don't forget to fund your upgrade by selling your old GPU at jawa.gg, and I can get you $10 off your first purchase using code OWEN10. This is where you buy, sell, and upgrade between gamers. Again, huge thanks for them sponsoring today's video, which allows me to dedicate the ridiculous amount of time it took to run all of these benchmarks. I hope all of you have an excellent day, but actually let me remind you that if you would like to see all of these side-by-side footage that I kind of had to skip through here for time reasons, it's an hour and a half of side-by-side footage, and I did make that available to channel members as a members extra, just as a bonus. So anyway, all the data was included in this video, but if you want an hour and a half of side-by-sides to pick through and look at, there you go. Join button can get you that, and I hope all of you have an excellent day.